In this video, we're going to look at how one function can call another function in your program. To motivate the topic, we're going to be looking at the problem of finding the distance between 2 points in a coordinate plane. So let's assume that our 2 points have coordinates x1, y1 and x2, y2. The distance is given by this formula here, and you'll notice that we have to perform one type of operation twice. We have to take the difference of two values and square that difference. Here's one way to solve this problem in Python. We begin our program by importing the math library which comes with Python because we're going to need a square root function that is in that library. Then we have a function that we define called square_diff. It takes two inputs, val1 and val2, and computes and returns the square of the difference of those two values. And you can see we're using the exponentiation operator to square the difference. Then we have another function called distance. This is the one we're actually going to call to compute the distance between the 2 points. It takes as its inputs the coordinates of the 2 points, x1, y1 for the first point, x2, y2 for the second point, and you can see it calls square diff twice. It calls it once to compute the square of the difference between the x coordinates. It calls it a second time to compute the square of the difference between the y coordinates. We then add those results up and assign them to a variable d, and then we pass d into the square root function which we're getting from the math library. And you'll see we have to do math dot square root to get that function because it's in that math library. We take whatever result it gives us and assign it to a variable called dist, and then we return the value of dist. And then in the global part of our program, we call the distance function passing in coordinates of 2 and 3 for the first point and 5 and 7 for the second point. It will give us back the distance, which we assign to a variable called dist, and then we print the result. Let's trace through this program in the Python Tutor visualizer. And don't forget you can access Python Tutor using the link on the course website. Now, I've removed the doc strings just to give myself a little bit more room, and I'm going to make one more change to the program that will help me illustrate an important point. So if you remember, we had this line here in our distance function that calls square diff twice and then adds up the results and stores it in a variable d. Rather than doing that all on one line, I'm going to do it in 2 steps. So first, I'm just going to assign d the result of the first call, which is the square of the difference between x2 and x1. And then I'm going to come down here and update d by adding the old value of d to the result of that second call, which computes the square of the difference between y2 and y1. So we click the Visualize Execution button, which brings us to this page, and then we're going to be able to step through it line by line. And you can see we start by importing that math module. Module is another name for library. We then define square_diff. We define distance. So at this point you can see that information about the module and the functions is in the global frame. And then we come down here and we make the call to the distance function, passing in the coordinates of the 2 points. And when we call that function, we get a new stack frame for distance. And you can see it over there on the right, and the 4 parameter values are in that stack frame. Then we come down here and we call square diff, and that's going to give us another stack frame for square diff, and we jump to that function. And notice how val1 is 5 because we're passing in x2 for that, and val2 is 2 because we're passing in x1 for that. We then go ahead and we compute the difference of val1 and val2, which gets stored in d, and then we return d squared, which is 9. Returning causes that stack frame to go off the stack. We're now back in the distance function, and you can see that the return value replaced the function call. The return value was 9, and it has been assigned to the variable d in this stack frame. So d down here in the distance stack frame is 9, at least for now. We're then going to make the next function call to square diff, passing in y2 and y1. So once again we're going to have a stack frame for square diff. Now val1 is 7, which is the value of y2, val2 is 3, which is the value of y1. We compute the difference between val1 and val2, which is 4. And now notice, if you look at the two stack frames for our functions, they both have a variable d. This variable d is the local variable that belongs to square diff. This variable d is the local variable that belongs to distance. So even though they have the same name, they are two different variables because they belong to different functions. We're going to return 4 squared, or 16, from this call, and that gets sent back to distance. And you can see we've now updated d in this stack frame to be 25 because the old value was 9, we added 16, and then we got 25. We're then going to take that d and pass it in to the square root function in the math library, and what we get back is 5.0. And you'll notice that we didn't get a stack frame for that function call because it was in that separate library, and so Python Tutor can't show us the details. And then finally we're going to return the value of dist, and that brings us back to the global scope, the global part of our program, and you can see that the variable dist down here, which is a global variable and is not the same as the variable dist that we had up here, it's getting assigned the return value of this function call. And we have to do that. We can't just use the variable dist down here and assume that we're going to get the correct value, because remember, the local variable dist goes away when the stack frame goes away, when the function returns. We don't have that variable anymore, and so we have to take the return value and assign it to our own variable dist if we want to be able to use dist down here when we print the result. And finally we go ahead and execute that print statement, and you can see that the output is the correct one.